Hey guys, we are going to go through sample exercise 16.6 along with the practice exercises. You're going to notice that this sample is going to ask us to refer to practice 6.16.5. I've already supplied you here with the given information, the hydrogen ion concentrations for the first and second solution. So let's follow the steps. First thing you do is analyze. Make sure you know what you have and what you need. We have hydrogen ion concentration, that's a given, and we need to find the pH. So our plan of action is just to use the equation that defines pH, negative log of the hydrogen ion concentration. So in this first problem, you see you've got 1 times 10 to the negative 12 power. We're going to input that 1, use the exp key, that means times 10 to the negative, or times 10 to a power. We're going to say it's 1 times 10 to 12, 10 to the 12, and then switch that to a negative sign. So 1 times 10 to the negative 12 is the beginning point. What we're going to have to do with that is take the logarithm, so hit the log key on your calculator, find its negative 12, and then since it was negative log, you've got to hit the negate key, and that becomes positive 12. Next thing that we're going to do on part B, when you look at it, we see that that's 5.6 times 10 to the negative 6, so we input that into our calculator first. It's going to be 5.6 times 10 to the negative 6 there. Hit the log again, and then negate, you get 5.2518. We round that off, and we get 5.25. Last step in our process is make sure after you solve to check that work, make sure that it's reasonable. And the way that we can do that is by seeing the starting hydrogen concentration has a power of 10 to the negative 12. So we expect that it should be somewhere between 11, 12, and this is 12 exactly since it's 1 times that power. For our second question, we see that our power was negative 6, so it should be on the order of somewhere between 5 and 6, and it's 5.25. It makes sense. So now that we've completed those, let's get into the practice. So our first exercise here, practice exercise 1, we have a solution with a hydroxide concentration of 6.7 times 10 to the negative 3. What is the pH of this solution? Now, I'm going to approach this like I would on the AP exam. I have a multiple choice question. I have to have number sense. I won't have a calculator for this section. So thinking that through, the first thing that I want to do is consider the path that I would take as I solve the problem. Well, we've got multiple options. We can go from the hydroxide ion concentration into the POH, and then from POH to pH. So that's one of our possible stages. What I could also do is take hydroxide concentration, turn that into a hydrogen ion concentration, and then a pH. Now, I personally always prefer getting to the power first and jumping through that if I can. It's a lot easier than dealing with powers of 10. So I'm going to opt to do the top step here. Let's erase my blue option. Now the hydroxide, this is where the mental math comes in. Hydroxide concentration was around a power of 10 to the negative 3. So that means my pH value is going to fall somewhere between 2 and 3. All right? So if I had a pH value between 2 and 3, I know this is not a 1, it's not 3, it's let's just say that it's somewhere right around the middle of that 2. So roughly a 2.5 on the POH area. Let's just say that. Let's think it in those terms. Well, if it's a 2.5 on the POH, I recall that pH plus POH is always equal to 14. So I can subtract 2.5 away from the 14 and get a ballpark figure that my answer should be somewhere in the 11.5 range. By looking at all of the options, I can eliminate a lot of these other choices, and I have 11.83 and 12. The best choice closest to this is going to be the 11.83. I know it's not going to be 12 because it wasn't 1 times 10 to the negative 3rd or 10 to the negative 2. Cool? So that is our mental math approach that we always do on these multiple choice questions. Second thing that we want to do, look here at practice exercise 2. Here in part A, we are given a hydrogen concentration 3.8 times 10 to the negative fourth power. And the question is, what is the pH? So we need to come up with an actual value. This is going to be like in a constructed response on the AP exam. Well, think back to our have and need. We have hydrogen, we need pH. So our plan is going to be using the negative log of hydrogen to find pH. So we solve that problem by plugging in our value. It's 3.8 times 10 raised to the negative fourth power. Find the logarithm and switch that with a negative. We get 3.4202. Rounding that off based on 2 sig figs, I get a pH of 3.4. Add the 2 in because I need 2 sig figs, and that's how we communicate sig figs with pHs. So that's what we're going to do for part A. Part B, now we have another solution. This time around, we've been given hydroxide. The goal is to once again find pH. What we're going to do with this is, again, think of our path. We can take hydroxide concentration, go into POH, and into pH like we did in the last problem. Again, I still think this is going to be the best approach because we're going to get into the power and then be able to use that pH plus POH is 14. We're going to plug in our value. First off, hydroxide ion concentration here. We're going to take the negative log to get into POH. So our 1.9 EXP key, negative 6 power. Find the logarithm, negative. We get 5.72 as our POH value. Now I've got my 5.72. We can take 14 minus 5.72, and we get 8.28 as a pH value.